In this video we're going to look at finding binomial probability, and I'm going to show you how to do it by hand in case you have to do it in exam 1 and also using your CAS for exam 2. So if we're going to find binomial probability, we need to be able to find this NCR value either using the Pascal's triangle or using the formula. And the formula for NCR is here. So from n number of trials, we're choosing R number of successes. We can write it like this, and it's equal to n factorial over R factorial multiplied by the difference between n and R factorial. So if you haven't seen a factorial before, it's just a shortcut way of writing whatever that number is times by every number one step down all the way to 1. So I'll show you an example. So say, for example, we wanted to find 10C3. So from 10 items, we're choosing 3. So you could see it just as well written as 10, 3 in these 3 brackets. So we put our values in where they were in the formula, so that it's n factorial on the top line, so 10 factorial over R factorial, which is the 3, times by the difference between the 2. So 10 minus 3 is 7 factorial. Now 10 factorial, as I just said, is the same as 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. That's a lot of multiplying together. But you'll notice that what we're going to do is we're going to divide 10 factorial by 3 factorial times 7 factorial. So if there was any way to cancel here, that would make our life a lot easier. And the description of factorial is if you start at a particular number, let's say we started at 7, and we took that section there, which is 7 times 6 times 5 times 4 times 3 times 2 times 1, that is in fact 7 factorial. So what we've got here is that 10 factorial is in fact equal to 10 times 9 times 8 times 7 factorial. And we can write it like that so that we can do some cancelling out and make it easier for ourselves to figure out what this is. So that's what I'm going to do here. So you can see that I've replaced 10 factorial with 10 times 9 times 8 times 7 factorial. We've still got times 3 factorial, which is 3 times 2 times 1, times 7 factorial. And 7 factorial will cancel with 7 factorial, and that just leaves us with 10 times 9 times 8 times, and on the bottom, 3 times 2 times 1, which is just 3 times 2. And simplifying that, we get 120. So the process, if you're doing this by hand, is write your top line out until you reach the largest of the 2 factorial numbers below. In this case it was 7, and then cancel down. And then simplify anything else that you can here. And the simplification that I did in this row, for those that are still asking, I said 3 went into 3 once, and 3 went into 9 3 times, and 2 goes into 2 once, and 2 goes into 8 4. That's where that line came from. So if we're doing this on our CAS, we're going to use the combinations capacity on our CAS. So if we go menu, probability and combinations, up pops this screen that looks like this. So you'll get NCR and then a blank here. It'll start the brackets. And what you put in here, it tells you the order. N goes first, and then our R goes second, and there's a comma in between. See the comma in there? So you just put that in and it tells you 120. Easy. So to find binomial probability, you need to know 3 things. You need to know N, which is the number of trials. You need to know P, which is the probability of a successful outcome. So realistically, you also need to know what is a success. What is a success? And then finally, you also need to know the number of successful outcomes that you want the probability to be for. So say, for example, if you had 3 trials, we had n is equal to 3, and the probability of success was 0.1, and what we wanted to know is what's the probability that x is equal to 2. Now, if the probability also fits the conditions for a Bernoulli trial, let's just go through those again. So our conditions for our Bernoulli trial are that there are 2 outcomes, the probability of success is constant, and that we have independent trials. If we have that situation, then we can say that the random variable x is distributed binomially, and normally we'll put some numbers here where n is and p is, and this is the definition often that we'll use to say that we're using binomial distribution. For example, if we do have a Bernoulli situation and x is distributed binomially with n as 3 and p as 0.1, we might be asked to find the probability that x is equal to 2. I'm going to show you how to do that by hand and using CAS. So here we go, let's do this by hand. So to do this by hand, we need to know that our n is 3, our p is 0.1, and the x that we're working for to find the probability of is 2. So we take our probability formula and we substitute our values in. And so what we've got here, the probability that x is equal to 2 is equal to 3 is our number of trials, and we're choosing 2. We want 2 as our outcome. Our probability of success is 0.1, and we're going to have 2 of those because we're getting 2 successes. Our probability of not a success adds to 1 with this value here, so it's going to be 0.9, and it's n minus our x. So from there, you can either use what you know about the patterns in combinations. So this is n and this is 1 less than n. So this should give us, when we simplify it, just the number n. So this will become a 3. We're going to have to do multiplying by decimals and raising decimals to powers as well. So I'm actually using the formula here just to show you that you can still do it by the formula. So I'm going to write my 3 factorial out as 3 times 2 factorial divided by 2 factorial times 1, and then the 2 factorials will both cancel with a 1 and a 1. 0.1 times 0.1 is 0.01. Okay, don't forget when you're multiplying decimals that the number of decimal places in the answer is equal to the total number of decimal places in the sum that you're doing. So here we've done 0.1 times 0.1. So our answer is 1, but we actually need 2 decimal places, so it's 0.01. And now we go through and multiply those together. So that simplifies to 3 times 0.01 times 0.9. So the numbers give us 27 as an answer, and we have 3 decimal places. So you can see I've got 3 decimal places in my answers. Now, one of the most common mistakes made in exam 1 when doing this by hand is the multiplication of decimals. People get those wrong. They say 0.1 times 0.1 is either 0.1 or they'll say that it's 1. So watch out for that. So using CAS to find binomial probabilities, we use the binomial PDF capacity on our CAS, and PDF stands for probability distribution function. And you'll find that on your calculator under probability distributions, and then you might have to scroll down to see it. Let me just get rid of that. You might have to scroll down to see it, but you're looking for binomial PDF. See here? So if you need to scroll down, just use your down arrow, or you can press, mine's the letter A. Just check what yours is on your CAS depending on your operating system, and then you can just press 5, menu 5, 5 and the letter A on the calculator if that's where yours is at. And then it'll pop up a screen that looks like this. Let me just zoom in on this because this is a little bit small. And it wants you to put in, it tells you what you want. Num trials is the number of trials, see N is 3. Prob success, our P is 0.1, and the X value that we're looking for is 2. When you press OK, this is what it spits out on the calculator page, and it tells us that our probability is 0.027. So you can actually type this in using the letters on your keyboard if you like, with your N. Let's just zoom in a little bit more. So you've got your N, then a comma, then your P, then a comma, and then your X. When you first try and put this in to your CAS calculator, oops, that went far too far. What you'll find on this screen is that this says that it's optional when you go to put it in on your CAS calculator. See, it says optional here. Let me just zoom in a little bit. See, it faintly says optional. Now, if you don't put an X value in, what it spits out in the calculator page is your N and your P, and then it gives you a set of numbers. And what the set of numbers are is this is the probability for X is equal to 0. This is the probability for X is equal to 1. This is the probability for X is equal to 2, and you can see that it's the same answer as what we got here. And this is the probability that X is equal to 1. So if you wanted to write the table of values for this particular probability distribution, you could do it using this function here. So let's have a go at doing some questions. So here's a question. A fair coin is tossed 6 times. Find the probability that 3 tails are obtained. Now we're in the middle of a binomial thing, so obviously it's going to be binomial, but in the exam you won't know what sort of probability it is. And so you'll have to run the Bernoulli test to see if you can in fact use binomial distribution. So we need to check, do we have 2 outcomes in this experiment? Yes, we do. We have head and we have tail. Is the probability of success constant? Yes, it is. It's a half every time we flip the coin, the probability of success. What is success, by the way, in this question? Let's define that. So find the probability that 3 heads are obtained. So heads are obtained, looks like heads, tails are obtained. So it looks like tails equals success. Okay. And then finally we need our trials to be independent. And they are if it's a fair coin and we're tossing that coin 3 times. So we can use our binomial distribution here. Okay, so let's go through the question. How many trials are there? The coin is tossed 6 times, so n is equal to 6. The probability of success, so we just defined our success as being tails. So what's the probability of tails? It doesn't say in the question, it doesn't have a probability listed, but it does say that we're using a fair coin, and a fair coin means that it has equal chance landing heads and to equal chance landing tails. So our probability of success, our probability of landing tails is a half. Find the probability that 3 tails are obtained. So we're looking for 3, x is equal to 3. So doing it by hand, we use our formula. So from 6 trials, we're choosing 3 outcomes. The probability of success is a half raised to the power of 3. The probability of not success is also a half because these 2 probabilities have to add to 1. And it's 6 minus 3. When we go through and calculate that, turn it into factorials. So 6 factorial over 3 factorial times by the difference of 6 and 3, which is 3 factorial. Expand that out and cancel it down. And what we have here is half to the power of 3 times a half to the power of 3. That becomes a half to the power of 6. So I've written out my 6 factorial down to 3 factorial. So I can cancel down my 2 3 factorials. Goes in once, goes in once. I also have 3 times 2 is 6. So that will cancel with that. That brings us down to 20 times a half to the power of 6, which we can in fact continue to simplify. Let's just move this up. We can in fact continue to simplify. We could write it as 20 over 6 squared, but 20 is in fact 2 squared times 5. So 2 squared times 5 is 20. Using our index laws, tidy it up a little bit more, and we end up with 5 over 2 to the power of 4. Using CAS, all we need to do is write down our N and our P values. So my exam advice is, whenever you get probability question, if it's binomial, write the N value down and the P value down. This shows the person marking your work that you recognise that it is in fact a binomial situation and you can use binomial distribution. Even if you can't figure it out, you'll get some marks, possibly, for recognising that it is in fact a binomial situation. So always write N equals and P equals. Even if you circle it in the question and write N equals and P equals, but better to write it on the lines. And then you just take your CAS calculator out. You don't even need to write anything else other than the answer there. Okay, so if you did it on your CAS calculator, that's the answer it would spit out. That's all you need to write. So we're going to have a look at the same situation with the fair coin being tossed 6 times, but this time we're going to look for a more complex probability. We're going to look for the probability that more than 3 tails are obtained. More than 3 tails are obtained. So our N is still 6, our P is still a half, but our X value that we're going to find needs to be more than 3 tails. So more than 3 tails means in 6 trials we could get 4 or 5 or 6 tails. Now, if we're going to do this by hand, it's going to be a little bit of a nightmare. But anyway, we need to find the probability that X is equal to 4 and add it to the probability that X is equal to 5 and the probability that X is equal to 6. And so you need to write the formula for each, which is what I've done there. And this time I've used what I know, 6C5 is going to be 6 because it's 1 less than the number at the top. 6C6 is 1. A half to the power of 5 times a half is a half to the power of 6. This is a half to the power of 6 because a half to the power of 0 is 1. I'm going to expand this out, cancel down the 4s, cancel down the 3s, and that leaves me with 15 to the half, 15 times half to the 6 plus 7 times half to the 6, which leaves us with 22 times X, 22 times a half to the 6. Can't even talk today. All right, so using a CAS, we need to use a binomial CDF. And the C stands for cumulative. And what it does is it takes the table of probabilities and starts adding up from X is 0 to plus X is 1, plus X is 2, plus X is 3. And you tell it which X value you want to start with at the lower end and which x value you want to finish it with at the top. And so you'll find it under probability distributions, and generally it's just underneath the binomial PDF, and you'll see that it's CDF. So you really need to make sure that you are tapping on the right numbers when you're looking for these binomial solutions. Okay, so we're going to put this into our CAS calculator. When we select binomial CDF, we get a box that pops up, and it looks like this. It asks us for the number of trials, which was 6. Our probability of success was 0.5. Now, our lower bound is the lowest allowed value, the lowest value that's acceptable for our conditions, and that was the value x equals 4. And then our upper bound is what is the largest value of x that also suits us, and that was 6. When you press enter, it puts this out, and so you could type this in if you like with your n as a 6, your p as a 0.5, 4 to 6, and it spits out the probability here. And just to show you that you get exactly the same answer, remember our 22 times a half to the 6? You can see you get exactly the same answer. So if you had a variety of these probabilities to calculate and you didn't want to go through this menu pressing thing the whole time, you can just use your CAS calculator to go up, copy this down to the next line, and then change whichever one of those values you need to change. Press enter and it'll pop the answer up for you. Much easier than doing it by hand. And finally, I want to show you an example of binomial distribution, binomial probability, and conditional probability, conditional situations. So here's an example. 5 out of every 1,000 bricks produced by a certain company contains a fault. If 100 bricks are selected randomly, what is the probability, correct to 4 decimal places, that A, none of them are faulty, none of the bricks are faulty, and B, less than 4 of them are faulty, given that at least one selected is faulty? All right, so let's do this first one first. So we need to think if we can use binomial probability. So we go through our lists of, are there 2 outcomes? Yes, there are, faulty and not faulty. Is the probability of success constant? Yes, it is. Whether one brick is faulty doesn't have an impact on another brick. And are they independent trials? Yes, they are. So we can use binomial probability here. And what we're actually looking for are whether the bricks are faulty or not. So in fact, our success, a successful trial, or something that we say is a success, is actually going to be a faulty brick. All right, so we need an N and a P, and I've already done it here. The number of trials is 100 because we are selecting 100 bricks. And the probability of success is the probability of getting a faulty brick. Now we know that 5 out of 1,000 contain a fault. So that means that our probability of having a faulty brick is 5 out of 1,000. For part A, we want to know the probability that none of them are faulty. So the number of faulty bricks we want is 0. And so we pull out our CAS calculator. Where's one I prepared earlier? Here it is over here. And we put our values in, and it spits out 0.6 blah blah blah, and we're going to go to 4 decimal places. So 4 decimal places leaves us with a probability of 0.658. So the second part says the probability that at least the probability that less than 4 of them, the probability of less than 4 of them are faulty, given that at least one selected is faulty. So we use our conditional probability formula, where that is the intersection of the 2 situations here. x is less than 4, x is greater than or equal to 1, divided by the second one. Now, a common mistake that people make in the exam is that they just think, and in many cases this is true, they just think that this is in fact just equal to just probability that x is less than 4. Okay? They don't worry about this at all. And that's not in fact correct, because I'm going to show you right now why that is not in fact correct. So we want the probability that x is less than 4. So on this little number line for x down here, I'm going to mark in a green dot for the values that are less than 4. So it's 3, 2, 1, oops, and I should have 0 here. Let me put 0. And we also need values of x that are greater than or equal to 1. So that will be all of these ones here and continuing on that way up to 6. The only 3 values where both exist are the numbers 1, 2 and 3. And so we pull those 3 numbers into our formula on the top line. Now, our second thing that we need to find is the probability that x is greater than or equal to 1. Now, that's a lot of finding. You could do it on your CAS calculator if you liked. No problems at all. You just put it in as a cumulative distribution function from 1 up to 6, or you could do it as 1 minus the probability that x is equal to 0, which we've just found here and already have on our CAS calculator. So now I'm going to do this on my CAS. So I'm going to find the probability of the top line, probability of the denominator is 1 minus the thing that I had before. Let me just zoom over this way so you can see. Okay, so this one here is this, because our allowed x values, the lowest one is 1 and the upper limit was 3. And you can see that I have used my answers here to find the answer at the end. Now, if you're going to write this down, you need to write, you want the answer to 4 decimal places. You want to go to 5 or 6 at least, 5 or 6. Otherwise, you're going to get a rounding error here. My suggestion is do exactly what I've done here. Go up and collect either this or this and then divide it by 1 minus whatever it was. Okay? So make sure that if you are giving your answer to a certain number of decimal places, that you don't round too early. Let me move this up a little bit. And that's what I've done here, to 4 decimal places.